All right, so this is 11.8, the review, right? And this is 3E. Okay, so this is a good one because it's like, whoa, this one looks really crazy with the x, sine x down there and everything. And yeah, it's a little tricky. Remember, what you can do is you can try to manipulate the equation a bit so that you simplify it before you integrate. So if you notice that you could rewrite this as two separate fractions, then you could change it a little bit to simplify it. So this is what I would suggest. If you have sine x over x sine x, if you write it like that, okay, x sine x, and then plus x cos x over x sine x. So that's something you can do, because what you would be able to do here is to simplify. See, the sine x the x goes over there. So you've simplified this a little bit to 1 over x plus cos x over sine x dx. Okay. All right. Now we have separate terms. This one right here is easy to integrate, right? That's just ln of absolute value of x. This one is cotangent x. So if we have an integral for cotangent x, if you knew that, you do that. But what I want to show you is that if you don't know that, if you don't go straight there, how do you do this? Well, you could do U-substitution for this one, okay? You could do U-sub here just for this part, because we have 1 over sine x times cos x really is what we have there, right? So if you did U-substitution here, if you did U is sine x, and du is, what's du? Cos x dx, right? So we do have an inside function, so sine x is inside of the larger function 1 over x, and we do have the derivative of sine x multiplied in there. We have that as part of the expression. So this is a good U-substitution candidate. And so if you just kind of take a pause on the outside and do this separately, then you would have 1 over u du, right? Because the dx is cos x dx. So there's du, and there's u. So if you just take, like I say, just take a little break and solve this one separately, then the integral of this, because really you can split this up, right? You can. Well, if you have expressions that are added or subtracted, you take the integral of each. Think of the polynomial, 2x squared plus 2x plus 5. You can integrate each of those separately. That's part of the rules of integration. You can separate them. So if you have a plus in there, you can treat these as separate. Okay, so I'm going to integrate this with U-substitution. And this looks funny right now, I get it. But I'm going to do U-substitution here, and I'm going to make sure I sub in my my x stuff back in later. This one is ln of x, right? Okay. This one is going to be what? Ln of u. Okay, and then we've got a plus c. Okay, don't forget your plus c, because there's no limits of integration. It's not definite, it's indefinite. So now I'm not quite done yet. I need to kind of get back to x, because it's all in terms of x, right? The original equation. So this can stay, ln of absolute value of x. This is going to be ln of, what is u? U is sine x. So do I have to do absolute value of sine x? Yeah, sine could be positive or negative, so it's no good. So we have to do absolute value because it's inside a ln function, right? Sine x could be negative. So I think, is that the answer? Is that the right answer? Who asked me about that? Is that the answer that they show in the back? I think this is correct now. Okay. So that's a good one to look at because of this right here. You know, it's like, ooh, how do I, okay, this one is easy to integrate this term, but this one's maybe not. So go ahead and do your U-substitution. Just take an extra couple steps and then substitute back in and make sure you plus C and you're done. Okay?
Oh, yeah.
How's that? Not too terrible? Sort of semi-terrible? Okay? Okay, all right, so that's 3E from the review.